Hi everyone, welcome to the next video on separation techniques. In this video, we're going to talk about chromatography. Chromatography has very interesting origins. When we look at the word chroma actually refers to color. And color in Greek, actually, the language. And graphy refers to writing. So just from the name itself, you get an idea of when we use chromatography. Very often you find in your textbooks that we use chromatography to separate ink, right? Writing in color, very often you find in your textbooks, the example given to you is we want to separate inks. I'll give you an example. Let's say I have red ink and I have blue ink, and I mix the two together to form a purple droplet. Now, this purple droplet, if I were to zoom in, you'll find that it is a mixture of the red ink particles and also the blue ink particles. On a very microscopic level, this is what it looks like. If I were to zoom out, this is what the purple droplet will look like. Now, I give you a challenge. How in the world are you going to separate the blue and the red after they've mixed together this way? Let's think back to some of the separation techniques we already learned about. What about filtration? Do you think filtration will allow me to separate the red particles, ink particles, and the blue ink particles? What do you think? If I were to, let's say, force the ink particles up to the filter paper. Here I'm going to draw a filter paper here. Imagine this is the filter paper, just a zoomed up version of it, and this is the pore of the filter paper. A pore is a hole, right? There are many pores in the filter paper. You find that the pores of the filter paper are too big. Both the red ink and the blue ink particles technically can still pass through. There's no way I can separate them. Therefore, we have to resort to another property of substances to allow us to separate them. This property we're going to look into today has to do with how substances is able to dissolve, right? I'm going to introduce a word to you. This word is solubility. We're going to use this particular property, solubility. We're going to use this particular property to help us separate the blue ink and the red ink from each other. Solubility. Put it very simply, solubility is the ability of a particular substance to dissolve in a particular solvent. In this case, I'm going to use water as my solvent. Okay, solvent is the thing that we dissolve a substance in. Solubility simply refers to how well a substance is able to dissolve in the solvent. Here I have the blue ink particles. If I were to zoom in, if I were to zoom in, this is the blue ink particles. If I were to zoom in to the red particles, this is what you see. After I've dropped a drop of the blue ink into the water, which is the solvent, and the red ink into the water, which is the solvent, now let's zoom in to see how well they dissolve in the solvent. As you can see in the for the blue ink particles separate out very well. They intermingle with the water molecules very well. And you can see that each blue ink particle has separated from each other. This is a clear sign that the blue ink is very soluble, right? You find that they have separated, they have dissolved very evenly. This is a blue ink. This blue ink has high solubility. Let's look at the red ink instead. Notice that the red ink is not so soluble. The red ink particles are still clinging to each other. They haven't quite separated from each other, unlike the blue ink particles. When we zoom in, if this is what we see, this red ink has lower solubility. Now we're going to make use of the difference in solubility to help us separate the red ink and the blue ink. Because in reality, the better the substance is able to intermingle with the water molecules or the solvent, the better and faster it will be able to travel along a piece of filter paper. Right, so now let's go to the chromatography setup.